Black tar hair.
All right. So 5.3. This section kind of like groups kind of some random straggling stuff with derivatives on it, and I think at the very end we start doing integration, which is exciting. I know you guys have been waiting for that. But we're gonna do approximating the tangent line. So basically, we are going to approximate the corresponding y value by using calculus. It's very exciting. Okay, so it says, in many instances, finding a value of a function is difficult or sometimes impossible. With the use of calculus techniques, we can approximate the function value by finding a y value on the tangent line of the function. Since this method involves using a linear function in a nearby point, it is sometimes called linear approximation or local linearization approximation. Local linearization or linear approximation. Those are things that I've seen. Anywho, all right, so we are going to be looking at the point 2, -2. So they have a picture of our little scenario here. So the equation is x squared plus y squared plus 2y equals 4. So you can see that if you graph this in Desmos, it creates a circle. And we're kind of zooming into the point at 2, -2. And we're going to use the equation of the tangent line passing through 2, -2 to approximate its corresponding y value when the x value is 2.1. Okay, so the idea of this is like to use calculus kind of like so that you don't have to use a calculator. Okay, so this was used back in the day before they had this super awesome technology at your fingertips. Okay, so it is important for you to appreciate what they learned a long time ago.
I have an argument to make.
I don't want to hear it.
No, you do. You do.
So what we're going to do is we're going to derive the function because we're going to talk about the tangent line, right? Nope. Okay, so anytime we talk about the equation of the tangent line, our first step is to derive. Okay, we're looking at the slope, right? We're trying to find the slope. Remember, the equation of the tangent line, if you forget this, is y minus y1 is equal to m times the equation x minus x1. Remember that?
No.
Uh-oh. Okay, so I need my slope. Okay, so I'm going to derive my function. So what is the derivative of x squared?
2x.
2x. Oh, wow, that's interesting. That was crazy. That was like magic right there. I don't know what happened. 2x. What is the derivative of y squared? Good. 2y, y prime. So you can either say 2y, y prime, or you can say y dy dx. I'm going to write y prime because it's a little bit less to say. Okay, what is the derivative of 2y? 2y prime, good. And equals 0, good. Okay, so in order to find my slope, I need to isolate my y prime, my derivative piece. So how would you isolate y prime? Yeah, some algebra. So how about we'll subtract the 2x first. Okay, and then you can pull your y prime out on the left-hand side. And if I pull y prime out of those two terms, what's left over? 2y plus 2. And then I would just get rid of that quantity by dividing it. And so my y prime, I don't know what is happening. Why is it doing that? Y prime is negative 2x over 2y plus 2. So you might want to simplify this. It is probably not completely necessary because we're going to do substitution. Okay, so what is the point that we're going to use to substitute in? 2, -2. So I'm going to write just notationally so you get used to this notation. Since my y prime was that equation below, I'm going to write y prime of 2, -2, meaning I'm plugging 2 into the x value and I'm plugging -2 into the y value. Okay, so I can say 2 times, or negative 2 times 2. On the bottom, 2 times negative 2. Wow, plus 2, that's a lot of 2's. So if we simplify, we get, what do we get? Negative 4 on the top and negative 2 on the bottom. So negative 4 over negative 2. Ah! Sorry, I don't know what I'm doing today. Is 2. Okay, so we just found that our slope is 2. Okay, so the equation of the tangent line at 2, negative 2 would be what? Y plus 2 equals 2. I love all these 2's. This is just wonderful. Okay, so now that I have my equation, I'm now going to do the linear approximation piece. Okay, so do you see how in A it says when the x-coordinate is 2.1? So guess what I'm going to do? Plug it in. I'm just going to take 2.1 and I'm going to plug that in. Yeah. So we're going to go 2.1 minus 2. So the point is that you should be able to kind of do this like mentally. Hopefully. Okay, so what is 2.1 minus 2? 0.1. So what is 2 times 0.1? Ah, good lordy. I'm really struggling today, you guys. I'm sorry. So what was it? 0.2, right? And then my last step would be to subtract 2, and my corresponding y value is negative 1.8. Okay, and that's what you're looking for. It's an approximation, so you could use, instead of the equal sign, you could use like the approximation.
Do we have to do that?
No, you don't have to.
It's recommended.
But it's recommended. You won't be deducted for that.
But it's recommended.
All right, so for B, the only difference is, now I'm just plugging in the same number. I can use all of the calculus that I used in the previous question. I have my linear equation, and now I can just plug 1.9 in instead. Yeah, so we can just do y plus 2 equals 2 times 1.9 minus 2. So what is 1.9 minus 2? Negative 0.1. So then I would have negative 0.1 times 2. Negative 0.2. And then if I subtract 2, you get negative 2.2. Good. So, oops, I forgot my little squigglies. Okay. So that would be about your corresponding y value. Pretty easy? Yeah, I would agree. All right, so number 2, this is our last question. This isn't too bad. All right, so if f of 2 is equal to 3 and the derivative at 2 is negative 2, can we use local linearization to approximate 2.01? So the nice thing about this is it looks scary, but it's way easier than the last question. Okay? Because they're like giving us all of the pieces, right? So the f of 2 equals 3, what is that giving us? The x and the y. So that is like the point that exists on our function. So 2, 3. So we can use that to write our linear equation. And then what is the derivative at derivative at 2 giving us? Yeah. That's silly looking slope. All right, we'll just, okay. I think I need to restart my laptop. All right, so if I have all the pieces, I can now plug this into my linear equation. So my linear equation is going to be y minus 3 equals negative 2 times the quantity x minus 2. Okay, so that's my linear equation. So now if we're going to approximate at the value 2.01, what do we do? Yeah, so we just plug that into the x. What was it, 2.01?
Yeah.
Minus 2. Okay, so what is 2.01 minus 2? 0.01. And what's 0.01 times negative 2? 0.02. And then we're going to add 3. So if I add 3 to negative 0.02, what do you get? 2.98. That's it. Right?
I feel like the ones we do as examples are never the same.
Well, they